Palladium. That is element 46 on the periodic table of elements. This is Norris Teaches Science with me, Mr. Norris. This is a physical science edition video. This is still a video talking about physics side of physical science. If you haven't watched the other ones, this would be your first physics video ever, which is kind of shocking that you haven't watched me since until now. But I digress. Let's go on to today's topic is wave parts. So your goal for this video, hopefully that you can say I can identify wave parts of transverse and longitudinal waves. The wave parts. These two wave parts are for transverse waves only. Those are the waves that go up and down, up and down, up and down. You have the crest. The crest, I'm circling them right now, are the highest points on a wave from top or the top of the wave. The trough, which I'm boxing right now so you can see them, the troughs are the lowest point of a wave or the bottom of a wave. All right, this little line here you see, that's something called the resting position, but we'll get into that in a moment. Longitudinal waves for wave parts. These only are on longitudinal or on those compressional waves. You have compression. I'm kind of circling those right now so you can see them. Compressions are areas where particles are close together. And rarefaction, that's how you say it. It's not rarefaction, it's rarefaction. Is where they're spread apart. I'm kind of bracketing them out. Because remember, in longitudinal waves, it's a back and forth motion. So you're going to get times where they come together really close and then times they spread apart. If you've ever played with a slinky, you would notice if you hold it between two hands and kind of bounce it between both hands, you have the points that are close together and points that are far apart. Now this wave part is on both of the transverse and longitudinal waves. We're talking about mechanical waves here because that's what we're going to mainly focus on in physical science. Wavelength. Wavelength is the distance between a point on one wave and the same point on the next wave. Usually when it's a transverse wave, we're going to go crest to crest or trough to trough. It's one of those two. On longitudinal waves, we're going to go from one compression to the next compression. Wave part, this is also on both of them, is something called amplitude. It's the maximum displacement from the resting position. All right, so on transverse waves, there's a resting position, and that's that solid line that the wave goes up and down on. That's resting position. That's where the medium would be without the wave. You would go from resting position to crest or resting position to trough for the amplitude of a transverse wave, the ones that go up and down, up and down. On longitudinal waves, the ones that go back and forth, back and forth, back and forth, you're going to look at how compressed the compressions are. So let's do some labeling of a transverse wave diagram. So pause real quick and kind of write these terms and sketch this wave real quick so we can then label it as I do it. Did you pause? Please pause. All right, I'm going to go forward. All right, the first thing I'm going to label is a crest. A crest is right here because it's the highest point of the wave. The next one is a trough. Trough is down here where I'm doing my dot and labeling it with B. That's the trough. Remember, trough is the lowest point of the wave. All right, let's change out my color and let's go to blue. Wavelength. We're going to do two wavelengths. You could do, actually I'm going to do three wavelengths. You could do crest to crest. You could do trough to trough. Or you can do, sometimes they like to do from one point here to another point here. And that is still a wavelength. All right, changing out the color. This time I'm going to pull up purple. Purple is going to be for amplitude. Amplitude is from resting position to crest or resting position to trough. So we could go here to here, and that would be amplitude, or from here to here, and that's amplitude as well. All right, new color. We'll get this. All right, wave height. Wave height is from crest to trough. That is wave height. And then the last thing I need to label is the resting position. This solid line right here that's in green, that is resting position. I lost my mouse real quick. This is resting position. Resting position is where the medium would be if there was no wave there. All right, it's like nothing's there, it's resting, it's not moving. But this is a transverse wave. So pause again if you didn't copy already, copy this down, label your wave. If you have different color pens, I would label it with different color pens or markers or crayons or colored pencils, whatever you have to do. All right, the next one you're gonna have to label. You should probably, you're gonna need to draw this diagram. So I'd pause real quick. I want to get a marker, my color pen thing on this program. Longitudinal waves have three things you need to know. You have your compressions. All right, compressions are the close together areas. Your raw refraction, which is your spread apart area. And then your wavelength is from one compression to another compression. So I would definitely pause this as well, write this down, copy this diagram down, because it's really important that you have that together. All right, the next thing we're going to talk about is something called frequency. All right, both types of mechanical waves have frequency. Frequency is the amount of waves that pass a given point in 1 second. And when we do frequency, frequency has a unit, it's hertz, Hz. Now in transverse waves, what we have to do, we have to count the top bottom pairs. So if you look at this wave over here, it's a transverse wave. And so we would do, this is how many waves would pass this point in 1 second. So we're going to need to see what the frequency is. So we would count one top, one bottom, crest, trough. That's one pair. And here's a crest and a trough. That's a second pair. So there's two pairs here. So this wave has a frequency of 2 hertz. In longitudinal waves, we would just count how many compressions there are. Let's practice this a little bit. So the top one, all these are transverse waves. Both of these are transverse waves. So you have to see how many top bottom pairs there are. So here's a crest, here's a trough, and I like to circle them. That's one pair. Crest, trough, here's another pair. Crest, trough, here's another pair. Crest, trough, here's another pair. How many pairs do we have? We have 4 pairs. So the frequency is 4 hertz. All right, pause the video real quick. See if you can figure out what the frequency of the wave at the bottom is. All right, I hope you paused. Let's look. Pair. Here's another pair. Another pair. I'm just going to keep circling the pairs as I see them. Remember, it has to be one top, one bottom. Say that you have just a top, that's half of a frequency. So you write 0.5, but if you have a pair, it's 1. So we keep doing this. All right, I got all my pairs. Let's look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pairs. So the frequency of this wave is 10 hertz. Now in real life, frequencies of waves are much more bigger than like extremely bigger than these numbers, but we're just looking at it as common sense so we can understand the concepts. But these are the different wave parts of a wave. I really hope you learned something. I hope you paused and you copied down some of those diagrams so you have those. But come back again. I'm Mr. Norris, and I'll see you at the next video.